linear this morning, so I'm going to have to re-record things. And then
You keep forgetting to record.
it's easy to do when I have to actually. Well, the Zoom would do it automatically, but I would rather do the screencast thing because then I can edit things if I need to, and then I forget to hit start. So that's the big thing. And then my hotspot died in the middle of linear this morning, and then for some reason the surface that I'm writing on now has a spot off to the lower right hand corner that the pen won't work on. So it's been an interesting technology morning. Any questions about anything before we get going?
I actually had a couple over the video, the confidence interval
Sure.
video we had to watch.
Yeah.
So when we're finding, I guess my question is like what we're finding. So when we're doing like, because when we find a percentile, we get like a value, correct? Like what that would, the value at that percentile. So like our confidence interval is basically a range where that value would fall in. Is that?
That's the idea. So you're looking for the spot where the spot in the order where the percentile would be. That's what you would find first, and then make it as symmetric as you can based on the order statistics to figure out your confidence interval.
Okay.
So let's see here. I can get my screen to share. Maybe. Let's just share the whiteboard. So when you have your, let's say y1 less than y2 less than whatever, let's say I do y10, y11, y20. So if I want a confidence interval for, say, the median, I know that the median is going to be here. Would be in the 10.5 position, right? Because it has to be halfway in between.
Right.
So that's what we find with the whole n plus 1 times p part. That tells you the position. And so what I mean by as symmetric as possible, depending on the percentile that you're given, you may not be symmetric within between two of those. But basically, you still kind of want to go around it. So intervals might be y10 to y11, or you might do y9 to y12, just trying to keep the same distance on either side of the position.
Okay, so even though like those values, because like I know like in the example, it was like one of the intervals was between, let me see, like 5 and 10.
Mm-hmm.
The middle was 8, so like 10 is only 2 away from 8, but 5 is 3 away. So is that what you mean by like as symmetric as possible?
Not with the actual values. It's with the position values that we're trying to be as symmetric as possible.
Okay.
Yeah, it's that. Yeah, I should have been a little bit more clear on that. It's not the actual values that you're trying to make symmetric around it. It's the position values that you're trying to make as symmetric as possible.
Okay. Thank you.
Yep, you're welcome.
And then I was wondering, would you be able to explain just a little bit more about the at least I, but at most j minus 1 part of the summation? Like.
Yeah, sure. So if you have, going back up to this again, let's just say I do this specific thing. Oops. Why is that not erasing? That was weird. It just scribbled. I told you, I am not having a good technology day. All right, so let's say we want to do about the median here again, just for a specific example. So if I want, say, the y9 to the y12. So I have this scenario. So remember, we're putting these statistics in order and then going to construct the interval. Well, if y9 is going to be less than the median, then we need at least when you do your random sample, you need at least 9 of the things to pop out and be less than what the median should be. So in order for this one to be less than M, we need at least 9 numbers from the sample to be less than M for that to happen. Does that make sense? That if this Y9 is going to be less than the median, then the 9 of the numbers from the sample have to be below the median in order for the 9th thing in when I put them in order for the 9th thing to be less than the median, I need to make sure there are 9 things that are less than the median if the 9th smallest is going to be. Does that make sense? Okay.
Yeah.
So whoops. I'm still sharing to you, but it flipped off to a different screen on me. So for this one, I want the 12th thing to be greater than M. So I need to make sure that this 12th order statistic is greater than the M. If I want the 12th, when I put them in order, and I want the 12th one greater than M, that means that my M is going to have to go in here at the very least, but maybe farther on down the line. So my Y11 could be less than M, but my Y12 can't be. So that's why it said at least, at most, 11 of the numbers must be. I don't know why I wrote to be. I should have wrote must be. Must be less than M. Oh, I did it again. I scribbled. Told you, it's not a good day. Told Dr. Stickles if something really, really bad happens during class, I'm just going to quit. And I just wrote Dr. Stickles on there. See? I just said her name.
They must be less than Dr.
All right. I told you, it is not a good day. Yesterday was better. I spent a good about 5 hours out in the yard doing some work. I burned a big pile of crap that I had in my yard for probably over a year. So anyway, so does it make sense why the most part must come in? Because my M has to fall, well, if I think about just the way the order comes up, the Y9 would be here, 10, 11, 12. You could have your M go from anywhere from here up to here. Right? It can fall anywhere in that range. So I have 9, at least 9, because this is going to be the 9th thing in my ordered list. So there's at least 9 that have to be less than, because my M can't go below that Y9. But there's also at most 11 of them that are in my list, because when I order them, this Y12 has to be on the top side.
Okay.
Does that help?
Yeah,
okay.
I think I was getting confused because I was looking more at like the values and not the position. So yeah, I think that makes more sense.
Okay, cool. Yeah, it's all about the position with it as opposed to the actual numbers.
Okay.
Other questions at all? All right, well, let's see if we can do a specific example here. Let's look at this. This is 8.4-7, where it asks us to, I'm going to get my keyboard, it's asking us to find a confidence interval about 0.95 about the median. So there's 20 of these data points, and we want to figure out a confidence interval for the median based on the order statistics. Now, there's a couple of ways I can get at this. I could rearrange these data so then I could put them in order so I can see them in order and figure out what the confidence interval is. But I can also use a command in Excel. If I remember the correct command, it's rank.
Dr. Joe, you've been cutting out for like 30 seconds.
Oh, of course I have. Because I told you, it's a bad technology day. All right. You hear me now, though?
The last thing The last thing we heard was about equal to 0.95.
Okay. All right, so we're looking for this confidence interval. So there's a couple of ways we can get at this. We can either take our data and then sort it, but we can also do, if I remember, we can do this rank command here, this rank.average command. So the way this command works is I want to tell it what the data point is in my set. So that would be the A1. And then I need to say the reference part here is in reference to the data set. So I'll select the entire data set here. And then I want to make that an absolute cell reference because I don't want that to change when I copy here in a second. And then the last part says that you can do it in descending order or in ascending order. And we want for our positions to be in ascending order here. So I'm going to put a 1 to have it in ascending order. So here's the idea behind this particular command. So the rank is going to tell us what the rank of the particular data value is in relation to the whole data set when the data set is put in order from smallest to greatest. The average part means that if there's two that are the same, it'll average the positions. Okay. So there we go. It went. So that first one has rank 4. Now I'm just going to copy this over and pull it down. And we can see what the rank positions are for each of these. Now, generally, when you're doing these confidence intervals for these confidence coefficients, you're not supposed to get two that are the same. They even say that, I believe, in the reading that they talk about since we're doing a continuous variable that we shouldn't be getting overlaps between these things. Unfortunately, of course, in one of the data they give you, two of the data points they give you in the problem, there's overlap, but at least it doesn't matter for our purposes as much.
Dr. Joe?
Yeah?
For your data point in E2, shouldn't that be 19.05 instead of 16.25?
Oh, well, that would be why it's wrong. Okay, thanks. Thank you for catching that. I didn't catch it last night. Okay, well, now we still do have two of the same, just not the same two. All right. That was easy fix. Thank you. All right. So what this rank command tells us here is that this 13.55 one that's in the same position here, that's the smallest. The biggest is the 20. And then we have the other positions that are in there. All right. So we're looking for this one, we're looking for a confidence interval for the median. The median would be at, if we were doing the halfway for the data set with 20 values in it, the median is going to be between 10 and 11. So one of our confidence intervals, so we could use the 10 and the 11. So just say the 10th and the 11th. The 10th value is the 16.4, and the 11th value is 16.45. Because again, our median here with the 20 data points would be at position 10.5. So we're going symmetric as we can about the 10.5. So this would be one of our confidence intervals. So one of the things that we might be interested in knowing then is what's the confidence coefficient. So again, if the median is going to be in between these two values, then at least 10 of them need to be less than the median, and at most 10 of them need to be less than the median. At least 10 of them need to be less than the median value, and at most 11. Or sorry, at most 10, because the 11th has to be above it, right? This would be y10 and y11. Y10 has to be less than, y11 has to be greater than. So in this case, we would just have the binomial distribution. The number, pardon me, the number in this case is 10, because there's 10 that have to be It has to actually be exactly 10 or less than the median. The number of trials then are 20 because there's 20 in our sample. The probability that you're less than the median is 0.5. And in this case, we don't want cumulative because, again, for it to be between 10 and 11, at least 10 have to be less than, and at most 10 have to be less than. So it's actually equal to 10. So the probability that happens is 0.18. So that's not a very good interval. That's certainly not going to be about a 95% confidence interval by any stretch of the imagination, right? It's a 17.6% confidence interval. All right, so let's try the next one down. Let's say we did the 9th and the 12th. The 9th value in the list is 16.25. And the 12th value in the list is the 16.65. In order for this to be able to be your whatever confidence interval, we would have to have at least 9 values less than the median, and at most 9 values, or excuse me, at most 11 values be less than. So let's do both of these. So we'll do binomial distribution. The number we're interested in first is 11. That's the at most part. Number of trials is 20. The probability, again, is 0.5 because we're talking about the median. And in this case, I do want cumulative. That will give me the probability that from 0 to 11 of them are less than the median. But I also want at least 9 of them. So I need to do the binomial distribution for 8, because I need to subtract. I want between 9 and 11, right? I want at least 9 and at most 8, so I need to, or at most 11, so I need to subtract off the first 8. There are 20 trials again. The probability is 0.5, and it's cumulative. So doing that computation will give us in between 9 and 11. Still not the best confidence coefficient here. So doing the next one here, because it's trying to get us to approximately 0.95. So if I did another one, I'm just doing them so you can see what they look like. 8th to the 11th. The 8th value there is the 15.75, and not the 11th, the 13th, sorry. The 13th value is 16.8. But again, notice that when we're calculating the probability, we're not using the values at all. We're just using our knowledge of the binomial distribution. For your 13th one to be an upper bound, we need at most 12 to be less than, or excuse me, yeah, at most 12 to be less than the median. Oops. Number of trials is still 20. Probability is still 0.5. And cumulative. And then we need at least 8. So binomial distribution 7, 20, 0.5, and cumulative. I could be a little bit more systematic with this. This is another reason why they gave you the table on the top of page 438 to give you some confidence coefficients for things. All right, so for this one, we've got about a 73% confidence interval. All right, and so we could do the next one. We're trying to get to 95. Let's jump down a couple and see if we do the 6th and the 15th, see if it gives us a little bit better. Pardon me. So the 6th one is the 15.4, and the 15th is the 17.05. No, apparently there was a range one. I don't know why I'm doing it this way then. That's all right. 14. Keep trying to type in the wrong thing. And then subtract off. But when I saw the one with the range, I probably could have been using it instead of doing the subtracting here. That's all right. It's good review. All right, so again, with this computation, we're doing at most 14 or less than, and then at least 5. And there we got something that's close to 0.95. That's okay?
So the idea is with using the binomial is we're selecting so many like of our out of our sample to be less than a number.
Correct.
Since we're, okay.
Yeah, that's right. So yeah, first when we're doing the percentile, the percent to be in a continuous distribution, the probability that you're less than a particular percentile is that p-value associated with the percentile. So your probability of selecting that value is equal to whatever that percentile probability is, and then you're doing basically independent and identical trials. So that's why it turns into a binomial.
Okay.
So then what would our answer be for this question? Would it be you choose the 15.4 and the 17.5 to construct the confidence interval?
Yep, that would be it. That's exactly right. That would be your answer. It would be the 15.4 to 17.05. This okay? So say you wanted to do something like find a confidence interval for the lower quartile, say. All right, so the first thing we need to do is figure out what the position is for where the lower quartile should be. So remember that formula is you take one more than the data points, number of data points, so in this case it would be 21, and then multiply by, in this case, 0.25, because that's our lower quartile is the 25th percentile. So the probability of being less than that is 0.25. All right, so your lower quartile would be at position 5 1/4. Now, if you actually wanted to come up with an actual number, a point estimate for your lower quartile, remember you have to do a weighted average idea. So you would go to position 5, which is the 15.25. If you actually, this is just to get an actual point estimate for your percentile. You would take the 15.25, because that's in position 5, and you want to go up 1/4 of the way between position 6, which is 15.4, and position 5, which is the 15.25. We're doing that linear interpolation idea, right? We're taking the straight line from the point 5, 15.25 to the point 6, 15.4, and finding out what the value should be at 5 1/4. Again, this is not the actual confidence interval. This is the point estimate. So your point estimate for the 25th percentile would be the 15.2875. All right, so if we want confidence intervals now, well, we can go between, the best we can do is go between 5 and 6, because it's somewhere between 5 and 6. We don't have a 4 1/4 and a 6 1/4 position, right? So if we're going to go around that and be symmetric, we would use 5 and 6, 4 and 7, 3 and 8, and so along those lines. So let's say we do the 3rd and the 8th. The 3rd one is the 14.05, and the 8th one is 15.75. So we want to do this one, let's try the binomial distribution range function since I don't know. All right, let's see what happens. I've never used this one before. Let's see what happens. 20 trials, it says. Okay, so the probability that you're actually less than the lower quartile is 0.25. So we'll use 0.25 here. Let's see. Let's see if it does 3 and 8. So 3 and 8. See what happens. That's what we want. So if that number is correct, then that should be about an 86.8% confidence interval. Let's see if that is right. 7. Oops. That's not going to be right. I want a 7 on that one. Not an 8. We want remember it's at most 1 less than, so I want this to be a 7, not an 8. Sorry about that. I want this number to be a 7 on the end because I want to make sure that it's at most 7. Like, well, it can't be right if it includes the 8. So let's see. We want 7, 20 trials, 0.25 probability, and then do the same thing for 3. So this has to be a 2. Hey, look at that. So I know how to use the command now. That made my life a lot simpler. All right, so this binomial distribution range, you just put the lower one that you want and the upper one that you want. So that made it a lot easier. So this is about an 80.7% confidence interval. So that would be a confidence interval for your lower quartile. If we do the 2nd and the 9th, so let's do the same thing here. Binomial distribution range, there's 20 trials, probability is 0.25. The number that your lower number is at least 2, and the upper number is at most 8. And so now we're a little bit closer to a 95% confidence interval. So your second one is 13.6, and your 9th one is 16.25. And that would give you a roughly 93.5% confidence interval for your lower quartile. Does that process make sense?
Yeah.
Yeah, are we okay with that? Any questions about it at all? Now you could use, sorry, go ahead.
If we were to do upper quartile, would it be 16.75? Or 15.75?
So if you did the 21 times the 0.75 for the upper?
Mm-hmm.
Yep. So then you would try 15 to 16, 14 to 17, and so on. Yep, that's right. Does this look like something you can reproduce?
Yeah.
Yeah?
I think so.
I think so? Okay. Well, I know that you're still working on your take-home test, and that's pretty much this entire section is being able to do this. So if this feels like something you can reproduce, I'm going to go ahead and let you have the rest of the time to work on different things, if that's okay with everybody.
It's not okay.
It's not okay? Sorry, Sam. Is it okay with everybody else?
Sure.
Yeah.
Thank you.
Oh, you're welcome. All right, so we will talk on Wednesday. I'll get a video posted up for 8.5 for the new hypothesis test that we'll also do for the median, which is a little bit more interesting. So we'll talk about that next time. But anyway, have a good one. Good luck finishing up your test and all those good things. So talk to you later.
Dr. Joe, wait.
Okay. I'll wait for Sam. Yep.
I'll wait for everyone to leave.
You're going to wait for everybody to leave? Okay.
Because I have a question.
Okay.